Okay, we're going to rework this problem in class. Okay, these are the things that we defined in class. The velocity in still water equals delta x over t sub s. The velocity upstream is delta x over t sub u, and the velocity downstream is delta x over t sub d. We want to rewrite all these equations so they're in terms of time. Here we go. So we got t sub s equals delta x over v sub s. We got t sub u equals delta x over v sub u. And then we got t sub d equals delta x over v sub d. All right. So these are the equations we want to use here. Okay. So moving on now. Okay. We're going to substitute that into this equation that we saw right here. Current, okay, versus still over still. Now keep in mind that each of these only tells us what's going on in one direction. So the time in still water total just equals 2 times delta x over v sub s. All right. And the time in the current, okay, total equals delta x over v sub u plus delta x over v sub d. Okay. So we now have that information. Okay, now we're ready to plug those into the corresponding equation. Okay, so we had, I'm going to rewrite this equation so that they have a denominator. Right, so we have Vd delta x over Vu plus Vu delta x over V sub d. Okay. We gotta put this in here, so now they have the same denominator. Now I can add those two things together. Right? So to simplify that, we now have delta x times v sub d plus v sub u all over v sub u times v sub d. And this is now equal to our total time in the current. Okay. For the other one, it's pretty simple. Okay, we already have that determined. Okay, so that was this right here. So T2 times delta x over V sub s. Now we need to plug that into the equation that they provided us. T current minus T still over T still. So let's put all that together. T current, which was all this, delta x times V d plus V sub u all over V u sub V r times Vd. Okay, I'm not sure, I had some recording issues there. Is my mic still going or not? Alright, I'm not sure where that got cut off there. I'm going to go ahead and finish up this problem. Okay, this is now over the total, which was 2 delta x v sub s. So here's our equation of interest. We're going to get rid of delta x, delta x, delta x, and reduce this. So our final equation, Vd plus Vu over Vu times Vd minus 2 over V sub s all over 2 divided by V sub s. Okay, and we're going to substitute in the numbers that we have for our particular problem. Okay, in class, the velocity downstream was 2.31 meters per second. Upstream was 1.35 meters per second. And then the product of those two, 2.31 times 1.35. Meters per second. Meters per second. Okay. There's that one, minus 2 over 1.83 meters per second, all over 2 divided by 1.83 meters per second. So I'm just going to plug all that in. When I do, I get the following answer on the calculator. 0.074. I multiply that by 100 to turn it into percentage, and I get the 7.4% that they're looking for. All right, that's the problem.